Hello 3D people, this is 3D by 3D and this is my old 3D Prusa which I am planning to modify in such a way that only the x-axis will be increased. My plan is to add two more heated beds on the left and the right side of the central one and keep the y-axis the same and also the z-axis the same. I will also like to keep as many parts from the older printer, for example these components which came with initial printer from the x-axis. Also from the y-axis I will keep this one from the front and also from the bottom, and I will print and I will modify only for the z-axis because I will use some aluminum profiles 20 by 20 millimeters and some M8 rods, and I will customize a little bit the frame. The big challenge will be how to connect the three hot end beds in such a way that will not be any issues with electricity. I don't know, something that will hit or not work. And I've started by placing two additional 3 millimeters holes on the right side and the left side. As you can see, there are also 2 millimeters holes from the initial supplier, which came. I am having the MK2A heated bed version. As you can see, the plus wire is a little bit black, so some with the time some heat overheat it, and it seems it's having some issues. But let's see if it's working as it is right now. So I've started the printer, and what I'll do is to increase a little bit the hotbed temperature. So I will set up around 32 degrees, only small amount, to see and to check if it started or not. Okay, it seems it's not working. I have some problems with this display, but you can see an error, mean temperature. It shows up on the LSD display. I have closed the printer and tightened a little bit these screws. Maybe something was wrong. And I will try again by going to control, temperature, bed, and again set up 32. No, it's not working. Again, mean error, mean temperature. After several attempts, I did some changes, meaning I place the older screws smaller, having the 2 millimeters in diameter, so M2, and it seems it works very well. That means by adding new bigger screws, the overall resistance of the head of the heat bed will change. So as you can see, it's working very well. The LED opens and the current flows through the heat bed. So yeah, that will be an issue. My thinking to solve this is to use the MOSFET to control the heat bed and the current flow. And also after a little bit brainstorming, I did a small change in arrangement of the screws. As you can see, if you go back in the video, the wires were how to say, vertical through the x-axis. So they were vertical, meaning there was a small surface contact between the wire and the heat bed. So what I did was to change the angle of the wire, having a small surface for contact. In this way, it seems everything is working very fine. Let's test it. Let's testing by increasing a little bit the temperature. Voila, it's working. So only by changing the surface contact area. So I was thinking, if that was the problem, why not using some washers? So I've placed 2 of them, and let's see if it's working or not. Control temperature, bed, and a little bit increase again. Oh, it's working. Really? Come on. Okay, frankly speaking, I did a previous test and it was not working. So I'm having some concerns about how the current flows through the heat bed. Because the purpose of using a washer was to place the wiring in a vertical position. As you can see right now, it's a little bit vertical, right? So right now it is in standby, the temperature, because it already increased. So as you can see, now we started because it was decreased, now we stopped. So basically this is how the heat bed functions. Okay, so that is for now. Being so, I will start assembling the frame, the new frame, and after that I will see how I will handle the heat bed connection. So the first step to start with is again the heat bed, because if I want to increase the surface, I will also need to buy 2 additional heat bed from a local seller, and I will need to come up with a solution to connect the 2 additional ones with the existing one by having the same platform, so I will not want to change the platform. So I come up with a simple solution by adding an aluminium corner like these ones. Okay, so as you can see, this is an aluminium corner which is assembled very well. I've also, by the way, the new heat beds are another version. They are MK2B, which means they have two possibilities of wiring, meaning 12 volts and 24 volts. Because my power supply is 12 volts, I have to use the pin 1, which is plus, for plus, so the pin 1 is on the left side, and 2, 3 with the minus. I already make the connections and also place some bolts on it for the new wirings, and as you can see, I have placed a small gap with a nut to increase the distance between the heat bed and the aluminium corner. Otherwise, there was the risk to make a direct connection, electrical fire or something else. So I had to isolate the head bolts in order to make them function. So this is my new increase or resize heat bed surface. So this is how my new heat bed surface will look like. Pretty much cool, right? So I will do another test only to check if the main heat bed is working or not, because frankly speaking, I really don't know how to connect all three of them. I have some doubts how to do it. Maybe using some MOSFETs, 3 MOSFETs for each heat bed connected to my power source. I have a 360 12 power source, as you can see, having luckily 3 pins for plus and minus options. One is already in using by controlling the main board and the heat bed. So yeah, let's see if it's working. I hope it will, otherwise it becomes very strange, right? Temperature, bed, and it's working. It's not working. No, it's not working. As you can see, our mean temperature rises again. So yeah, I'm not sure exactly what happens. why previously time it was working and right now it is not. Maybe it also have some issues with the thermistor, or who knows why. But it's good that it's not having a problem by not using the washers. Maybe you are wondering why I do all this kind of tests before assembling the new frame, because I want to see if it's working as it is or not. So I come up again with as you can see, angle wired, so increasing the surface contact, and it seems it's working very well. So again 32 temperature, and look how it's starting, right? So this is a little bit concern from my point of view, because yeah, I want to make a good connection between all three heat beds, and this is the main issue. The next step that I need to do is to make some room on the table for the new printer. And the new frame is this one. As you can see, it's a very long frame, about 1 meter length and 50 centimeter in height. I have printed some profiles 20 by 20, and I have stick with the aluminum profile by printing another corner, and at the end of them I have placed this adapter for M8 rod. My plan is to connect the two sides of the new frame by an M8 rod, something like this. And unfortunately it is very long, so I need to move this nut until this head. Something similar with this. As you can see, 1 meter is a little bit long rod. I have placed the nuts in the place. Also I have an adapter here to connect the y-axis with the x-axis. Similar with this assembly. So my plan is to connect in this way both axes. And with the heat bed in place, it starts to take a new shape of my new extended 3D printer. And I finally managed to add the y-axis. As you can see, it's already mounted. And I fixed the y-axis with the x-axis by using these tower connectors printed by myself. Um it took some while to mount the nuts on the road, about 1 hour and a half, because it's a long M8 road, about 1 meter in length. So moving one nut from one head to the other head, it takes some time. That's actually the disadvantage of using this kind of support. You can also use, and most of other 3D people are using aluminum frame, but because it's more expensive, I adopted this kind of cheap solution by using an M8 rod. So the mounting is very stable, it moves very smooth from one side to another, which I like it very much. And I want to say something else. As you can see, there is a small distance here which remains outside the frame, and that's because the rod and the aluminum profile have the same length, which means if I will not use this corner, so let's say this vertical profile will be assembled here, down it will not be remain enough length for using the nut. So that will be an issue that I took it in consideration from the beginning. And I was telling you this because when you are planning to do new projects, you have to consider every kind of difficult issues that might occur in your developing. The next step is to find a way how to connect the z-axis together with the x-axis on top, and that will be a new challenge because I need to reconfigure it, or redesign these parts. There are many other users that use different solutions for this. But my goal is to reuse the existing parts from the previous or from the initial printer. And this is how it looks like with heated beds, all three mounted. Pretty much cool, right? How nice, it's moving, all three of them. Nice, very nice. I like it very much. Now it's a kind of messy on my desk, but I wanted to show you because I wanted to keep also the triangle plates from both sides. Look how I managed to fix them without any screws. I have printed out this kind of piece. As you can see, it will be mounted in this hole. Something like this. And after that, easily you can slide into the profile. Why I wanted to use these existing plates? Because of the mounting of the PSO and the motherboard. Nice, very nice. It's a little bit wobbling, but it is very stable, as you can see. So it's, for me, it's enough. So it's very good. Now we're starting to look a new printer. After mounting the PSO and the motherboard, it seems that the wires from the PSO don't get to the motherboard, but this will not be a problem because they are simply wires. So I will replace them with longer ones. But what I will be doing with the X carriage, because it seems it's going only until here, and I have the heated beds longer, I think. So look until when the extruder will be on the maximum X until here. So I don't like it, because it will remain a panel that it will not be covered. So what I can simply do is to resize a little bit the Y towers, the profile towers, so making them, I don't know, until here, maybe adjust them to be closer to the heat bed. Otherwise I will need to rethink a little bit, or to use some adjusters here, because yeah, that would be a problem. Otherwise the printer will not work. Until then, I have continued with my designing the new parts for the new frame, and I have designed for the Z motor axis this component, and on the right side it looks okay, but on the left side I have a little more issue, because when I designed it I was not taking into consideration the large component that includes the motor on the X axis. So if I move if I move this two, it will become unstable, and yeah, that will be an issue. So I need to find another way, or to redesign this to make it a little bit larger, or to adjust the profile to be closer to the holder of the motor. Yeah. And the gap is roughly around 5 centimeter. Yeah, it's not it's not too big, but it's not also too small. So maybe I will reprint this holder, and I think that will look better, because if I move this profile tower to the right, it will remain a big gap here, maybe around 5 centimeter, so outside, and it will look not so good. The extruder carriage looks okay, it's moving very nice. Of course, the issue with the wires are not solved and yet. Maybe I will rethink the direct extruder because of the weight of it. It's a little bit wobbling because of the long y-axis. It becomes a little bit unstable. Of course, I did not also place the top holders on the z-axis, but I don't know, maybe maybe after that I will see if it's still wobbling or not. It starts to look nicer, isn't it? I have finished designing and printing the new components for the Z left axis. As you can see, it's a large distance between the profile and the motor, but I finished that is not moving very much, and also the motor is stable on the table, so there is no gap here. When designing, I have a big issue with this small part here, which come inside of the profile. So I estimated around 2 millimeters, but when I place the bolt and the nut, it was not assembled very well, and it was wobbling, so I had to polish a little bit to make it smaller, around, I don't know, 1.8 millimeters. And I was telling you this because when you designing new components, you need to be careful, otherwise you will have some problems that you need to solve or to, I don't know, redesign. I have also placed the rubber band on the x-axis and also the glass. Fortunately, in my country there are men who are selling different shapes of glass as you required, and that's a good way to know if you are planning to redesign your heated beds area. Another way, instead of the glass, you can use aluminum foil, but Yeah, you have to cut it for the specific area. So let's get started. I will open the printer. I must say that I move the motherboard from that location basically in the middle of the printer because of the wiring connections which came from the PSO. And right now I'm doing a simple test of moving the axis because I just want to see how it's going. So I'm moving the x-axis right now. Let's see how it's going. Oh, nice. Nice. Unfortunately, there is a small noise here on the right side. Not sure why. Also, the rubber band is roughly 2 meters in length. As you can see, it has to be around 1 meter up and 1 meter down, so that means roughly 2 meters. Let's check the y axis. The y-axis. Oh, very nice. I have placed the glass because I wanted to check the weight of it, if it's okay or not. And now let's check the z-axis. Oh, nice, 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 nice. I like it. I like it very much. And down. Yep, that's okay. That's okay from my side. I will need to reconfigure, or I am planning to reconfigure the end stop mounting because they are old and they are broken, some of them, and I need to print them again. And also I don't know what exactly to do with the motherboard place, where to place it, because yeah, if I place it here on the left, I need to come from this motor, which is the longest distance to the motherboard, and it's barely touched the motherboard. Yeah, I have also keep in the future, I don't know if I want to place here a bearing just to not wobbling the z-axis road. Yeah, I like it what I did until now. It's rough. It's it took me, I don't know, around 2 weeks designing, printing, thinking. You have to take all kind of things in consideration, and I was thinking, if I make it in 2 weeks, or I don't know, only to redesign this printing, I was thinking how long it took the first man to build this kind of printer, I don't know, in the 1980s. because the first 3D printer was developed in the 80s. So yeah, that's good to know. Better and better. I have completed redesigning the end stops for the x-axis and the y-axis. I have placed it this time on the right side. As you can see, last time it was on the left and now it's on the right, and that's because look, when you look from top to bottom, you see there is a small distance from the rounded nut that came from the heated bed, and that's create enough inconvenience to not hit the end stop lane. So that's a big issue. I have placed this clamp, red clamp, to make it larger from the rounded nut. But after that, I was thinking, why if I was not placing on the right side? As you can see, there is no gap here, so easily it's touching the end stop right now. So my plan right now is to auto homing. So let's starting it, and let's give a little auto home to see what is happening. Okay, it seems that the y-axis and the z-axis are working fine, except for the x-axis, which I don't know why is not working. Okay, so after testing, it seems it was from the belt tensioner. Yep, now it's working all fine. Okay, that's good to know. Now I will want to check the bed, meanings I will like to heat a little bit the bed. No, it's not working. Okay. Oh no, it's working. That's good to know. It is working very well. Okay. Okay, it's working. Nice. It's working without a MOSFET, so I was using the same setup, which connects the wires through the motherboard directly, and of course again the same issue with the surface contact area. So after heating up, it stops, and that's good way to function. Let's do another test with the nozzle. Control temperature and nozzle. Let's raise a little bit the temperature, 40 degrees. Okay, it seems it's working also. This one. Okay, unfortunately my LSD is not displaying very well characters, but it's working very well, so it reaches the temperature of 40 degrees, which is good to know that is working very well. Okay, so this is my setup until now for the new frame extended of my previous printer. What it remains to do is to work on the nozzle and place the extruder here, or make it direct one. If I want to use the direct one, then I have to rethink a little bit the wires, because the length is too short, and if the nozzle will be on the most right side of the bed, then it will not, the wires will not reach the motherboard, so that will be a problem. So I have to extend the wires, as I did here. If you look here, I extend all the wires that came from the nozzle and thermistor, and also the fans. I have to extend them by, I don't know, roughly 30 centimeter, and yeah, that's was a long time to do that. Okay, so that's it for now. I like it how it stops and starts again the heated bed. Also the nozzle is working. Okay, the end stops. Okay, so it remains only the extruder to reconfigure it, and also the two heated beds which are extended my area. So that would be the biggest challenge of this project. And after auto homing, I was trying to move on the x-axis the extruder, and guess what? There is a restriction from where you want to move, meaning it cannot move more than 200 millimeters. So there is a restriction. As you can see, I cannot move more than 200, meaning I need to change the firmware to increase the X maximum length. So after opening the Marlane, you must go to configuration H, and then you can search for X max position and check all the possible lines that will appear, comment the line and copy and paste and change the value. In my case, I have a bed which maximum is 640 millimeters, and then save, and don't forget to copy the folder of Marlin before applying any changes. So file, save. And after uploading the firmware with new settings, let's see if I can move the x-axis more than 200 millimeters. Okay, wow, 202, 222, wow, where is going? It's going to the end. It should go to the 640. So this is 600, and basically it's above the maximum of the heated bed, which I don't like. So I think I have to reset yeah, 600. Strange. So basically from the end stop of X it should be around 580. Yeah, 585. Now it's going to 0. Yep, it reaches 0. Or maybe, yeah, I'm also losing here 1 centimeter. So from the head of the nozzle right down, so it should be around 1 centimeter gap between the end plate. So 1 centimeter, but again I thought the length from here to here is roughly 640, so I have to measure it again. And the meter says almost 640 millimeters. So why is it going beyond the end of the heated bed? That's strange. That's really strange. I think I know what is the problem. It's all about calibration. The printer is not calibrated. So at 640 millimeters, the nozzle is roughly about, I don't know, 3 centimeters from the end of the plate. Good that is not going too far. So I have to calibrate the printer. I have also moved a little bit the end stop for the x-axis to the left a little bit with 1-2 centimeters, and yeah, if I press the auto home, look how nice is moving. So the auto home should be, as you can see, the head of the nozzle, it's almost on the vertical line of the y-axis, so it's reaching, so the starting point, it's okay. So what I have to do right now is calibration. And another improvement what I have done is to redesign a little bit the belt holder, because it used some clips, and it were outside of the area of the nozzle, and reaches, because I have also redesigned the end stops. I had some problems when homing, because of these clips which were used before, and they were not fit inside of this end stop, and the homing was not doing very well. Playing with the printer, I have discovered another big issue. After homing, if I want to move the x-axis till the end, so I will move it till the end. The end means 630 degree millimeters, so 630. That's very important. So 630 in my case, with the setup, it almost reaches the vertical line, right, from the end. But if I want to go at the beginning on the same route, so basically going back from 630, if I want to go till 0, I like how it moves, but when it reaches the end stop, meaning here, it seems that it remains 10 millimeters. So why is that? So if I started from end stop to 630 and goes to the right 630 millimeters, if I want to go back 630 millimeters, it doesn't go back 630, it goes back only 620 millimeters, because it reaches the end stop and it remains 10 millimeters. Why is that? Can you please tell me why is that? Because I really don't have any clue. It remains 10 millimeters, as you can see. Of course, my display is bullshit, but Please tell me why it remains 10 millimeters. It should be from the belt because of the long distance. That's not a good situation, because I will have prints with one way to the right of, I don't know, 100 millimeters, and when it goes back it will be 90 millimeters, something like that. Yeah, how can I solve it? After playing a little bit with the printer and the moving of the nozzle, I have discovered that the tension in the belt was too low, so I have tightened it a little bit more, and now I have another value for the X steps per millimeter, which is 74.5. If I want to keep this value permanently, then I have to modify the firmware and upload it again. Let's make an auto home, and now let's move it till the end. Again, I have the issue when returning to the start of the x-axis, but the difference is 1-2 millimeters. So first time I move it to 200. 200 means the initial value of the one bed, so it is at the value corresponding to the first heated bed. And now let's try to move it to the end. So I have 634 from what I've seen. So as you can see, it's at the edge of the third heated bed, so at the end. Okay, so let's see if it's returning or remains some gaps. Yeah, I didn't know about this issue when returning the nozzle. So I will stop until it reaches the end stop, which means when it will make it red. Oh, it seems it's okay right now, 0. That's good, because previous attempts I had 1-2 millimeters until the end stop, and yeah, that's an issue, right? So that was the calibration for the X. The Y was necessary to recalibrate. Also the Z, I didn't modify them. So yeah, that's the calibration until now. It remains to for the extruder to rethink a little bit the setup. So having the Excel file from the 3D printer supplier, I have a list with Marine and with the menu tree. And if I go to control menu, motion, I have the motion menu, and I have here the MSG X steps, which I will copy and then go to Marlin and Control F, check the search all sketch tabs, find. And I have here defined X steps per millimeters. And I click again find, find. And clicking on that, here I have X-axis, Y, Z, and E extruder, but I don't see anything related to the values changes. So another way to find where to set up the values is to search directly 18.5, which comes when you open the printer. In my case, the values, so the initial values of the, oh, so there it is. So I have here defined default axis steps per unit, which is a vector, an array with 4 values. One of it is multiplication with a factor, but I'm interested, so I presume, because as you can see, there are 3 values with the same value and only one is different, but I presume the first one is for x, so I will change it to, in my case, 74.5. The y-axis seems to be okay, and I have here an issue because I don't know why this factor is, and before changes, make sure to keep the old values. So I will comment this and modify date, modified, and the date, for example 22nd 01 2024, and the comment, and now keep the new values. So I want to have a copy of the initial values which came with the printer. Okay, so these are the new values and these are the old ones. So yeah, verify. If you have some errors, then I suggest to search for them. I also had some uh, errors regarding with the version of the C++ compiler. and I have to search a little bit for them. So everything looks okay, so I will upload and then I will check if the firmware with the new values. So let's check it out by going to control, motion, and last four values. 74.5. Unfortunately, my display it's a crap right now. 80.5. So the Y steps, the Z's 395, and the extruder 102. Okay. Okay, looks okay. And finally, I have a cropped solution for my new frame. I have placed the extruder at the middle of the frame. I'm using a Bowden. Now I'm doing some test of moving, and I will also reuse the support for the filament, my filament holder. The printer moves okay. What I have an issue is at the ends of the both sides of the y-axis, because it slowly moves down by 0.5 millimeters, so the nozzle is not reaching the plate until in the middle of it. So that is my concern. Maybe in the future I will add 2 additional rods at the both the heads to stabilize it a little bit more. So yeah, that's my new 3D extended printer. I have almost finished assembled the printer together with my new cooling system of the extruder. I have redesigned the fan for the blower. As you can see, it's looking as a turbo fan blower. It has 2 blowers on the back side of them. Pretty much cool, right? And in front of it, it has the normal 40 10 fan, which cools down the middle part of the extruder. Okay, that's for the extruder part. What I noticed and what I was saying about almost finish is that I have discovered a major issue regarding the X axis, and that is related to the tension of the belt. When I tighten it up, it seems that the lower part it's moving towards inside. So if you look from this side, you can see this part is a little bit outside of the line. So that's because it has a little angle made between these two profiles from PLA together with the profile from aluminum. And that's an issue because I don't know how to tighten this part. I cannot move towards outside every time, and when printing, yeah, that would be an issue. As a solution, I was thinking to place a T frame here and tighten these three parts together, and another one which is more complicated, and I need to reassemble all the printer, is to replace these two profile with an aluminum profile and move it this one a little bit up. So yeah, that will be a solution. So let's auto homing again to see how it looks. It's good that it's not so noisy, because I see different variants of the blowers with a different rotation per minute. It seems there are different types. But I like how it looks like now, how I have designed it. So it seems that it has a little gap at the end. But if I move towards the middle, the gap is reduced to almost zero. And again, it's increasing to the other end. Oops. So my blower is not so stable when it moves, and that's because of the cable. Maybe I have to place some new parts to tighten better, but now it's only for testing purposes. Yeah, it doesn't work. I'm in printing test right now, trying to print something, and it seems that it's only working on the red heated bed. On the black ones it doesn't work, and that's because of the small gap between the glass and nozzle. Yep, look how messy looks at it. Before applying or connecting the MOSFET to the heated bed, it's important to test it before. And to do that, you simply need to connect the MOSFET to the PSO unit, and the control input of the MOSFET to the motherboard, where the heated bed was previously connected. In my case, I don't know, usually there is D8, D9, D10. In my case, it's writing on the motherboard, it's writing the heat bed minus plus. It doesn't matter because I have MK2A heated bed version. It doesn't matter the polarity, so you simply connect the control into the motherboard. So let's start before power on, as you can see, there is a small amount of current in the MOSFET, but once you will power on, it will become zero. Now, if so the functionality of the MOSFET is as follow. When there is no current in the motherboard, so there will not be any current in the control in, so the output of the MOSFET will be zero, which is in my case. If we will set up the temperature of the bed to a higher value, then we will receive a current flow from the motherboard to the control in, a smaller one, which will make the output of the MOSFET to be switched to on, and we have the current flow 12 volts. In my case it's with minus because I have switched the polarity of the digital meter, and but if I will switch again, I will have a plus. So let's do it. I have switched the connectors from the digital meter, and as you can see right now is showing with the plus value 12 volts. From what I see is that the minus it's on the right and the positive it's on the left side of the MOSFET, as you can look at it as I do right now. You can also see the blue LED from the MOSFET which is on when it receives current, and also the green ones from the motherboard. So it will receive current until the heated bed will be reach the temperature desired. and yeah, it's looking okay. I must mention, because this is the second MOSFET I'm using it, because the previous one was broken. So if you want to test to see if it's broken or not, or if the MOSFET is always switched to on, you need to do this simple test before connected to the heated bed, because if the MOSFET is always switched to on and you didn't check before, if you connect it directly to the heated bed, it happens that the heated bed will receive current, and in my case this terminal was slightly damaged, and the smoke appeared after a while, and it's not a good thing, you know. And yeah, it's better to test it. So let's switch to off the temperature of the heated bed. Okay, so look, right now it's 0, so the blue digital pin of the MOSFET is also 0. So that's the setup when you wish to connect a MOSFET to the heated bed. In my case, I have 3 heated beds, so I will use 3 MOSFETs, but for testing purposes I only bought only one to see how it's working. It's my first time when I'm doing this setup, and yeah, I'm curious to see how we'll work with 3 of them, because I have a PSU unit which has 3 pins for positive and 3 pins for negative, so that's enough in my case, because I have 3 heated beds. In case you are using, I don't know, 4 heated beds or more, then yeah, you need another PSU. I have redesigned the heated beds. I have reused the X-axis rods. There were 2, and it seems they are having same length with the Y-axis, so that was a good way to decide to reuse them. And it only remains to redesign the frame for the heated bed, only for one bearing, which remains only to guide the heated bed. There is also a little adjustment here that needs to be cut, but I decided to leave it as it is. So one frame on top of the other, and yeah, it looks very nice, as you can see. And I have also added the new profiles on both sides for more stability, and it remains to reassemble. And I have also added a second blower, so now I have a dual blower. Looks pretty cool, right? I like it. I hope it will also have the effect as I wanted to to have. And this is how it looks with the heated beds on the new platform. I have added the springs at the both edges of the new extended heated bed. Looks nice and it moves smoothly. I like it very, very, very much. I have reinstalled the printer, and my new attempt of printing reaches me out with another issue, which I didn't expect it. As you can see, the distance between the blower and the hotted end, it's roughly around 5 millimeters. So when it reaches the end of the heated bed on the axis, it's reaching these nuts that I have placed before, and it seems I need to cut them because it's not good to have. As you can see, if I'm going right now towards the blower, it seems that they will look, they will hit each other, and that will be not good when printing. So if this is the maximum, actually those from the black heated bed are smaller than ones from the red one. So basically this is as you can see, it's hitting the blower. So I have two solutions. One is to redesign the blower or to make an adjustment to redirect the blower. I don't know, making it parallel with the x-axis. Right now it's parallel with the y-axis, and I like it how I design it because I wanted that the airflow should not have any corners. So blowing in a direct direction makes it very powerful. So yeah, and the second one is to cut the bolts or to buy another ones. Roughly, I don't know, I approximate around 3 by 6 millimeters. So maximum length. So let's starting with the test. First time is to make an auto home to see how it's going. Nice, nice, I like it. Good. So basically small, there is no much uh, gap between the glass and the nozzle. So I will, yeah, and before starting, I wanted to show you the MOSFET that I am using for the heated bed. I am using only one for now, and uh, I hope I will install two more because I have three heated beds. So let's try a test. As you can see, the heated bed it's running via MOSFET. Connections are as follow. The PSU and the motherboard are connected directly via the MOSFET. So the plus and minus value are on DC input, and the heated bed is on the output, and of course controlling from the motherboard where the heated bed was previously connected. As you can see, the MOSFET is running very well. When it receives power from the motherboard, it opens, and the output to the heated bed is same as the input from the PSU. So in my case 12 volts. So I like it very much. Now I'm waiting for the nozzle to reach the temperature for extrusion. So after it reaches, in my case, 200 Celsius and 65 on the heated bed, I have a short delay. That's the sound for starting it. I need to remove this component, which I don't like. Okay, it seems that it has a long gap, so it doesn't reach the glass. My second attempt. Let's check it out. Still a gap. Look how it collects all the filament And my first line, okay, now it seems it started to print something, but not so well. And that's because it's still more gap between the nozzle and the glass. My third attempt. By the way, for gluing, I am using some hairspray. So no, I don't like it. My fourth attempt. Yes, that's better. It is much closer to the glass and it stick to it. Look how nice it's moving. Okay. It was very important to modify the sides of the heated bed to add these new platforms, and also I have reused the springs and use them on each corner. Unfortunately, I have this problem with the blower because I didn't think it will reach the ball from behind. But yeah, that's engineering, right? You have to take all things in consideration. So my first square, this is my first square. How nice it looks. The print is almost 1 hour and a half, so I will check it later how it's going. And yes, it's not a square, it's a rectangle. It's a long rectangle. I have a small gap here, but this is the offset of the print, so it's okay. I have some noise here from the fan, which cools down the extruder. And the blowers are set up to start after printing the first layer, so from the second one they will start. I will see if from trepidations they are moving away, because I didn't finish the design. I have to add some support for them, but I'm waiting to see how it's going without it. So the MOSFET it's okay. The temperature it's only for the red one. So after installing the two MOSFETs for the black ones, I will have the full power of temperature. But let's see if with the cold one it will work or not. Because I have glue it with a hairspray. Maybe they will stick till the end of the printing. So right now at the second layer the blowers are starting. Until now it's looking okay, I like it. At the edges it seems that or maybe it is from the shadow, is not gluing very well. But I hope they will not move away, or sometimes it seems that they are rising up a little bit, and I'm not sure, but it seems that it's starting to, in the corner, to rise up a little bit. And also I have another issue regarding the length of the printing. It seems that it's smaller than how it was designed. So that means I need to adjust the steps per millimeters from the firmware, because I have readjust the belt, I have tensioned it more, and it seems that I need to recalibrate it again. As you can see, in the corners of the printing, it seems that it's with white, and look how it starts to move away from the glass, and that's because there is no heat on it. It's cold, and only in the middle I have 65 degrees. Yeah, so I think I will stop it, because it's useless to continue. And now the moment of truth. I have wiring based on the wiring diagram. I have wired the three MOSFETs to the PSU. As you can see, I have 3 pins for plus and 3 for negative. And I have connected only 2 of them for testing purposes. These 2 is more exactly. And blue and red ones are coming from PSU, and this MOSFET is going to the red heated bed, which it doesn't require the way where you connect it. So plus or minus, they are both with the same color, red, which came initially from the supplier when I bought the first time the printer. But for don't know any reason, I have kept the negative pin to the right and the positive to the left. Same or vice versa here. From the black heated bed I have negative on pins 2 and 3 and plus on the first one. So this from the right is the plus pin, and I have connected the second one and the third one by using direct copper wire. As you can see, there is no protection on it. It is a simple loop made of copper, but this is my concern because I don't know if this connection will work fine or it will heat, and I don't know, something bad will happen. And I have also the digital multimeter, which will connect to the black heated bed, because I would like to know if the red one will stop, also the black one will stop, and vice versa. Both MOSFETs are connected via control in using these wires, and both are going to the motherboard on the heated bed pins. So let's start it. Let's see if something will blow up or not. Okay, doesn't. My first attempt, because I did not plug in the source. Okay, so let's start it right now. Okay, 0. That's okay because there is no current flow in it. The display is okay. It's showing the correct temperature of the room. So let's starting up. I don't know. Let's see if it's working or not. So I'm going to control temperature, bed, and increase a little bit to 36. Let's see if it's starting. No, it stopped. It stopped. I have a current flow of 141. So I will stop it. Okay. So it doesn't work. It doesn't work. Why is that? This one is a little bit heat. This one is not. But this one is a little bit heated up. Okay. Okay. I will try the next test. The next test is to remove the red ones and keep only the black one, to see if this connection is working or not, because it is very important. But for that I need to replace the thermistor to have the temperature control of it. But before that, I have another test in mind. I have disconnected the heated bed, the black one. I have kept only the digital multimeter to the pins to check. Okay, now it seems that my MOSFET is broken. It receives always 12 volts, even though it is not controlling. So my MOSFET is damaged. Luckily I have another one, the third one, and I will switch and check what voltage receives the heated bed when I change the temperature from the motherboard. I have reconnected the good MOSFET, the third one. I will switch on the power, and yes, I have 0 current volts on this one. Okay, so this one is working. This one should work also too. This one is broken, so I move away. So let's change again the temperature, because right now the heated bed is not connected, the second one. It should work only the red one. I have 12 volts, but the red one is not working. Why is that? Why is that is not working? Okay, I will stop it. And switch again on to see if it's broken or not. No, it's not. Okay, so something happened on the red one, because it's not or because of my pin connections, because I have, yeah, this one is not, it's loose, it's not very well tightened, and look what happened. I have tightened it a little bit better. Let's see how it's going right now. Yes, it's working, it's working. So that was the problem, tightening up connection, and also it's working the second MOSFET, so the voltage it is from the second MOSFET. So right now I'm waiting to reach the desired temperature, and now it's stopped, so now I have 0, and shortly it should open it again. So the control in is working very well in parallel, so I have used the parallel connection between the MOSFETs on the control in. But what is not working is is the connection over there. Yeah. I'm trying to do another test. I have reconnected the black heated bed to the MOSFET and check if it's working or not. So I have checked the red one, it is working, okay. So it receives the power right now. And right now I will check the second to see what is happening. No, it's not working. It's not working. Let's check it out if it's broken or not. Yeah, it's broken. Okay, so I have broken the second MOSFET. Beautiful. As you can see, it receives always 12 volts. And luckily the first MOSFET is working, so that's a good thing to continue and rethink why the black ones are not working well. So the problem is over there with I'm wondering if not minus, it's only on one pin instead of both of them. I'm not sure, because when I search on the internet, it shows up that I have to connect both of them, 2 and 3, to the minus. Yes, as you can see, it's working, the rear wadding is working, but the black one, the MOSFET, is always showing 12 volts regardless the control in. I'm doing another test right now. I simply connect the PSO to the black heated bed directly, and that means I will not use the MOSFET, I will not use the motherboard for controlling it. I simply connect the heated bed to the 12 volts unit supply. And the reason doing this is that I would like to check the current flow in the heated bed on the 24 volts terminal. And it seems that it's working very well. It's also heating up, but slowly. And right now I'm thinking to do another test by changing the wires from the red ones to the black one and connect it to the motherboard on the 12 volts size to see if it's working or not. But before doing that, I was thinking to do another test and connect or reconnect the wires to the 12 volts directly to the power supply. And as you can see, the negative wire is having two terminals which connects to both 2 and 3 pins from the heated bed. I have used some electrical shoes, two of them connected on the same wire, and let's check if it's working or not. No, it's not. It's not working. Unfortunately, it's not working. Okay, so I have an issue here. After some more tests, I have discovered what was the main issue. The surface area contact. Previously, I have connected this this positive wire on the vertical position, and right now it's on the horizontal, and also on the negative ones I have increased a little bit the surface area contact. So if I will start again, look how nice is working. So if you are planning to do this kind of changes in your 3D printer, make sure to have large surface area contact on your terminal pins. I did not use the soldering way because I wish to unmount these wires. I don't know, in the future, I don't know if they are something broken, or I don't know, in time. So I will stop it because it's becoming a little bit hot, which I like it very much. So what it remains to do is to replace the MOSFETs and reassemble all the stuff. Finally, after several attempts, I have succeeded to finish the testing of the wiring connection, direct one, because I have successfully succeed to broken up the third MOSFET. So look how nicely they are working, all three of them. So basically this kind of test you need to do before connect the heated bed to the MOSFET, because if you make a wrong connection on terminals, you have the chance to broken up the MOSFET, as I did. So right now I have to take into consideration or to replace this module entirely, or to change only the transistor. I've seen there are some suppliers who sell only the transistor, and I have to only to replace. That will be a cheaper solution. And regarding the pins connections, look what I did here. On the plus terminal, I have placed a gasket from PLA, because it seems that if I connect directly the nut to the electrical shoe, it seems it doesn't work. Also on these ones I have loosened a little bit. Yeah, so if you are if I tighten up more, it seems it doesn't work, and here it seems it's okay. Yeah, so you have to take many into consideration to make this kind of setup. After a break of 2-3 weeks because I had to wait to receive the new small bolts of 5 mm length. I have also placed them in the right position. As you can see, they are small enough to not touch the fan blower. And I've also purchased the new MOSFETs. They should work fine, and my plan is to replace all 3 MOSFETs because they are broken with the new ones, and see how they work. Because during a test, as you can see, the temperature of the black heated beds are different from the red one. So I think they are increasing faster than the red one. And you have to be careful when you will want to replace the MOSFET, because it has to be the same code. For example, it has to be the same case, and some other characteristics as well. So I have obtained it to purchase exactly the same code as the original one. First of all, it has a screw here that needs to be removed, and after that it moves freely. It needs to be remove the solder from these 3 pins, and after that replace with the new one. Let's see if it's working, because I have some doubts that it will not work, because the soldering is an industrial one, and my pistol is not so, it's not, I don't think it will work, but let's try it. It seems it's working, but I need to press a little bit more. Yeah, it's working. That's good. But somehow I need to do it on all 3 pins in the same time, otherwise it will not work. with this finger I move up and down to make some room. But yeah, unfortunately you need something with three to do it in the same time. And finally I have removed it, but after using a tool to pull it a little bit, because yeah, I have move up and down to make some room, and pull it out. As you can see, it's almost the same case, with the small difference. What is important is to have the same code, because otherwise it will not work. So right now I will try to make these holes, to remove what is in here on each one separately, because right now I can do it. And after that I will try to insert the new MOSFET and see if it's working. Finally I have managed to make a hole, but still it's very hard to remove the soldering. I have to use something similar with the nail, but also you need to be careful to not touch the other pins, because it will not work out. Okay, one hole. I have another 8, because there are 9 holes in. And look, a little mistake here. I have to clean it up a little bit here. Yeah. And finally I have managed to clean up all the holes, and right now I will insert the new MOSFET. Of course there are some garbage here that needs to be cleaned up. Still didn't finish. Yeah, beautiful. Back in business. So let's see how. So usually it should work very well. Insert, and screw again. I'm not sure if I will leave it as it is or cut these ones. For testing purposes, I think I will only soldering and leave it as it is. So basically I will place the bolt and that's it. That should be okay. And this operation needs to be done for all 3 MOSFETs. Yeah, very good. I like it. It's not an easy task, this part of soldering, because I am doing it manual, and everything that it's doing by man and not by robots is not so perfect, but it's almost perfect. Okay, so I have finished for all 3 of them. This is how it looks like. The new MOSFET replacement. Hope it will work. Let's testing it out. The first test is to make sure that the heated bed is working. So I have connect the heated bed directly to the power source unit, and it's not working. Why is that? The green LED was not opened. Okay, it seems that I had problems with nuts. So as you can see, it's working directly, and I have to be careful with this thing, because this is the main issue, that MOSFETs are broken. The next test is to connect the heated bed to the MOSFET and check if it is closed. So right now it should be closed, and the green LED should not open. Yes, it is not open, so that is good. Also the red ones is open, so that means it's working. Okay, and after that I will need to connect the motherboard, and also to connect the MOSFET here, and also to connect the motherboard. Okay, so right now I have connected also the motherboard. The motherboard with my broken display. And now I'm trying to open the gateway of the MOSFET by going to control, temperature, bed, and rising up a little bit and see if it's working. Oh, look how nice it's working. Unbelievable. How glad I am. How glad I am. Perfect. Perfect. And I presume that it will also stop and reopen again. It reaches the temperature, so I have set up to 32 degrees. Now it stopped, and it should start again, confirming that the MOSFET is working. And I did a good job. Come on, come on, come on. And of course I need to wait for all three of them. Oh my gosh, look at what happens. I have kept also the black one. I will stop it because if I don't have a control to it, basically I was running the two heated beds in parallel, but one was the red one was controlled by the motherboard, by the 3D printer, and the black one was directly connected to the power unit source, and it's not good because if it's not controlled the temperature, it might broken up the resistance, and you need then to replace all the heated bed because you cannot do anything else. So once again I have started the 3D printer, and also I have disconnected to the black one. Let's see if it's restarting. So right now it's working normally, and I have to do for all the other two that remains to be replaced. And yes, because there is a problem of the speed of heating, which is different from the black one and the red one. I'm not sure what I will do, but I'm thinking to decrease the temperature by 10 degrees of the red one. So for example, if the previous time was set up to 65, the new setup will be 55. So decrease a little bit because it's important to have an average of the temperature of the three of them. It seems it doesn't open, or it takes longer to cool down and reopen again. Maybe I should set up a higher temperature, but yeah, Oh, look. So finally, after 2 minutes, yeah. So it's working. Look how nicely is. Look how nice it's working. The new replacement for the MOSFET. Finally, after a long hard work, I have managed to replace all the 3 MOSFETs. And right now, this is how my 3D extended printer looks like. I have placed the MOSFETs right over there. I have also placed a garnish here. And also from the PSU unit. Let's see how it's working. So basically, right now they are all 3 on the off position. And after setting up the temperature for the bed, it should start. And yes, as you can see, they are all 3 working very well. The blue light LED indicates that the MOSFETs are on, and the green one from the red heated bed indicates that the current flows in it until it stops, all 3 of them. And as I mentioned before, the temperature it's a little bit higher on the black ones than the red one. I'm not sure why, but because I have the same voltage on all 3 of them. But yeah, it will not be a big problem because I need to have temperature on the both sides. And I have another issue, and I want to mention it before closing the video. As you can see, after placing the varnish, while I move the heated bed frame, it will be a little bit obstructing it by the Y stepper, and I have to place it over here, but that will be in the future. I also have a little bit problem with a crack, yeah, and that is not a good thing, but it's working. Let's do an auto home just for yeah, I was a little bit worried that something bad will happen. So yeah, that's my 3D extended printer looks like. Everything works okay right now. And be careful with the surface area contact, because that's a problem. If this wire will move a little bit, it will not make a good contact, and it will make the MOSFET broken, and that's not a good thing, right? Right now I'm waiting to start again. Yes, as you can see, they are all 3 working very well. And let's move a little bit to the Y, because I don't want to make pressure on the wire. Yeah, so I have to move a little bit the I have to move the Y stepper, Y end stop from this to this end, and to make some room for the wires to move freely. Here I also have a little bit pressure. So basically that's how it looks like. So happy 3D printing, and hope I will see you next time. Bye bye.